Picture a glass of water sitting on a marble table in a five-star hotel in Dubai. It looks perfect, clear, clean, untouched. But here's something many people don't think about. For every single glass like this one, a massive machine on the coast had to pull in nearly double that amount of seawater. Half of it became the water you're looking at. The other half, heavier, saltier, and invisible to anyone lying on those postcard-perfect beaches, got pumped back into the ocean. Before we go further, if you want to keep seeing the hidden engineering systems behind the world's most glamorous cities, hit subscribe right now, because what I'm about to show you reveals one of the hidden engineering systems behind modern luxury cities. A quick note before we continue. This video is an independent analysis made purely for educational purposes. Every figure, capacity number, and projection mentioned here is based on publicly available reports and data. This is not environmental, engineering, or investment advice, just an honest look at how these systems work. Now let's get into it. Dubai is a city built in one of the world's driest climates, making its water system one of the most remarkable engineering achievements anywhere. It has some of the greenest golf courses, the most extravagant infinity pools, and gardens that often look like they belong in a tropical rainforest. How does a city built on sand pull that off? The answer is desalination. And by the end of 2025, Dubai's installed capacity to turn seawater into drinking water reached nearly 500 million imperial gallons a day. Demand has continued to rise alongside Dubai's rapid population and tourism growth. This isn't just infrastructure, it's one of the most ambitious engineering feats on the planet. But here's the part many people overlook. Desalination doesn't create water. It splits it. And whatever it takes out has to go somewhere. Let's break down what happens to 1 cubic meter of seawater the moment it enters one of these plants. First, a portion becomes what they call product water. This is the clean, treated water that ends up in your shower, your kitchen tap, your hotel pool. That part is the success story most people talk about. But the leftover salt doesn't simply disappear. It gets concentrated into a thick, dense liquid called brine. Then there's the heat. Especially from older thermal plants that boil seawater, the water going back into the ocean is often noticeably warmer than the sea around it. And finally, there are leftover chemicals, anti-scaling agents, chlorine, coagulants, substances used to keep the machinery running smoothly, which can end up mixed into that returning brine. So while the city keeps the clean water, the sea receives the concentrated brine and treated discharge that remain after the desalination process. Here's where it gets interesting. That brine isn't like normal seawater. Because it's so much saltier, it's heavier. And instead of floating off and blending into the waves, it tends to sink. It can creep along the ocean floor like a slow-moving current, spreading across whatever lies beneath it. Now, to be fair, this doesn't mean the entire Arabian Gulf is turning into a toxic wasteland. The Gulf is enormous, and it has natural currents, especially through the Strait of Hormuz, that help dilute and disperse much of this load on a large scale. But just because the ocean as a whole can generally handle it, doesn't mean every patch of seabed near a discharge pipe is unaffected. Creatures that live anchored to the ocean floor, corals, seagrass, shellfish, can't easily move away from warmer, saltier water settling over them. They often have to endure it. But the story doesn't end with brine. Let's actually follow Dubai's water through a single day. Early morning, intake pipes along the coast start pulling in millions of gallons of seawater, and the separation process begins. By mid-morning, that purified water is already flowing through five-star hotel showers, restaurant kitchens, and the sprinklers keeping imported tropical plants alive in desert heat. By afternoon, office towers, malls, and residential buildings are pulling heavily from the same supply. By evening, that water, now mixed with soap, food waste, oils, and everything else from daily life, drains down into the city's sewer system. And by midnight, it arrives at municipal wastewater treatment plants, like the one in Jebel Ali, which has expanded its capacity significantly over the years to handle the load. So understand this clearly. Brine and sewage are two separate streams, and Dubai does treat its wastewater. But both streams, one way or another, eventually return to the same sea that the city depends on for everything. This is where Dubai's relationship with the ocean becomes layered and, in some ways, contradictory. There are three areas depending on that water staying healthy. First, marine life itself, the seagrass beds, coral patches, and microbial ecosystems that form the base of the coastal food chain. Second, the coastal economy. And here's an interesting point. A luxury beach destination doesn't need to be physically damaged to lose value. It can lose value simply if visitors start questioning what's in the water. And even when hotels aren't fully booked, the pools still need to stay full, the lawns still need irrigation in extreme heat, or the landscaping can die off. So water demand often stays high even when tourism slows. And third, Dubai's own water security. The desalination plants need relatively clean seawater to function well. If coastal water gets too warm or algae blooms from nutrient pollution spread, intake systems can clog and the cost of producing drinking water can increase significantly. In other words, Dubai doesn't just need the sea to look beautiful for tourists. It needs the sea to stay healthy enough to keep supplying its own taps. Now here's something many people overlook. Geography. Man-made islands like Palm Jumeirah added significant amounts of beachfront to the city, but they also changed how water physically moves along the coast. Before these structures existed, currents moved fairly freely along the shoreline, sweeping warm or concentrated water away naturally. Now, these large artificial formations create semi-enclosed lagoons where water doesn't circulate as quickly. This matters because the longer water stays in one place, the more any heat, salt, or chemical buildup tends to concentrate there instead of dispersing. Dubai didn't just build a city next to the sea. It reshaped some of the coastal geometry that influences how quickly that sea can clean itself. To their credit, Dubai is actively addressing this. They're building longer outfall pipes with diffusers that push brine further offshore into deeper water where it disperses faster. They're shifting away from older thermal desalination toward reverse osmosis technology, which uses high-pressure membranes instead of boiling, reducing the heat discharged back into the sea. And they're investing in recycling treated wastewater to irrigate parks and golf courses instead of pulling fresh seawater every time. These are genuinely thoughtful, forward-looking solutions. But here's a math problem worth paying attention to. Even as the technology gets cleaner and more efficient, demand for water keeps climbing, often faster than efficiency gains. Dubai's official target is to push desalination capacity to over 700 million imperial gallons a day by 2030, a significant jump from current levels. So picture two lines on a graph. One line is efficiency, steadily improving. The other line is demand, often climbing even faster, driven by more hotels, more residents, more pools, more landscaping in the desert. A cleaner liter of water means less if the city is also producing far more liters overall. Dubai is generally improving how it manages each drop, while also creating more drops to manage. So, what happens if this system comes under real strain? It probably won't look like a dramatic, visible disaster from a satellite. The Gulf's natural circulation appears strong enough to prevent a sudden basin-wide collapse. The more realistic risk is local rather than global. It can happen when several factors overlap in the same spot: a concentrated discharge point, slower water circulation caused by artificial coastlines, and rising background temperatures from broader climate trends. When that happens, an early sign might be a small patch of seagrass that quietly dies off, or one section of seabed that goes quiet. It doesn't need to become a regional catastrophe to become a meaningful financial and reputational problem for that one stretch of coastline. So what's the way forward? There are a few paths worth considering. One is pushing brine further out and diluting it more effectively with smarter technology, though that mainly delays the issue rather than resolving it. The second is turning waste into a resource by extracting valuable minerals like lithium and magnesium from brine before it reaches the ocean. A promising approach, though current cost and scale make it difficult to implement everywhere. And the third, the least flashy but arguably most effective option, is reducing demand, fixing leaks in the city's grid, encouraging low-flow fixtures in hotels, and replacing thirsty tropical landscaping with native desert plants that need far less irrigation. None of that makes for a dramatic headline, but it may be one of the more sustainable paths forward at the root of the problem rather than just managing its symptoms. So next time you see an infinity pool stretching toward the horizon in Dubai, remember, there's no hidden river feeding that view. The sea remains the foundation of Dubai's water system, supplying the source water while also receiving the treated byproducts of that process. Dubai can keep building bigger, smarter machines to pull fresh water from salt, but it can't build a second ocean. If this kind of breakdown opened your eyes to how these hidden systems actually work, drop a comment telling us which city's hidden engine we should expose next. Share this with someone who needs to see it, and make sure you're subscribed so you don't miss what we uncover next. One last note. This video is an independent breakdown made for educational purposes only. All figures and projections reflect publicly available data and reports, and nothing here should be taken as professional, environmental, engineering, or financial advice. Thanks for watching, and we'll see you in the next one.